the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New and Geocentric Consultants Hugo New Corporation Sustainability Seminar Series, co-sponsored by Brown and Caldwell, H2M Architect and Engineers, BEM Systems, Catalyst Group, and WSP.
Well, thank you so much. Thanks for that introduction. Really happy that Steve got me involved with this seminar series. So yeah, I wear a couple different hats at WSP and happy to talk about both of those. But today I'm going to focus on my role leading our Future Ready innovation program. So first, I will just tell you a little bit about WSP for those that aren't familiar with the company, and then I will explain our Future Ready program, and we'll talk about future trends, and I'll give some project examples. We'll use menteemeter a few times throughout the presentation, so when we get to that first question, I will pull up menteemeter. So WSP, we're one of the largest global professional services firms. We have over 55,000 employees across the world. And just looking at the US, we're close to 12,000 employees across 200 offices. And we serve clients across all markets. So we provide planning, engineering, design advisory services to clients in the following markets: transportation, property and buildings, power, water, environment, and in the US federal programs. And we also have some national services, our advisory services, climate resilience and sustainability, which is where I sit in the organization, and then our PMCM practice. So we work on large infrastructure projects across the US, and a lot of really exciting work. And our Future Ready program is a global innovation program that really unifies WSP. We work with colleagues across the globe on a lot of the major projects, and it's really about developing a mindset within our culture. So, one of the things I wanted to touch on is that, we have as a provider of sustainability and resilient services to our clients, it's really important that we walk the talk. So just sharing a few of our global and US commitments. So from a global perspective, we've set a commitment to achieve net zero within our value chain by 2040. And we've set interim science-based targets for 2030. As part of that commitment, we've committed to 100% renewable electricity by 2030. And we also recognize that, while it's really important to manage our own and reduce our own emissions, our project emissions is where we really have the biggest opportunity to make a positive impact. So that's where Future Ready comes in, and where we have this additional focus on reducing emissions in our projects, because we don't have as much control over those emissions, because the control often sits with the client or other partners on the project, but we have influence. And so we are committed to first of all, measuring those emissions because they can be difficult to quantify across all the different projects that we work on, and then working with our clients and other partners to reduce those emissions. And then just looking at the US, we've been carbon neutral since 2019 in our direct operational greenhouse gas emissions. And we last year, we made a commitment to the Structural Engineering Institute 2050 commitment to reduce embodied carbon within structural systems. Okay, so now I'm going to pivot over to menteemeter. And I'm realizing I probably have to change what I'm sharing. Sorry about that. Okay. Okay. So for menteemeter, you go to www.mentee.com. You see it at the top of the screen here, and then type in this code 22641818. And so this first question is just, what's the first thing that comes to mind when you hear future ready? So I'll give everybody a minute to get there. Great. Resilience, sustainable, definitely on the right track. There you go. Climate resilience, innovative, prepared, planning. Great. So yeah, these are all aligned with future ready, zero emission. So yeah, so this was just to get everybody thinking about future ready. And now I will switch back to the presentation and talk through it. Okay. So I mentioned Future Ready is it's a global innovation program. It's driving a mindset shift within WSP. So as we work on projects, we always want to be thinking about, is this project future ready? And Future Ready is a program that we developed because we know that our future world's going to be very different from today's in many ways. And we work on large infrastructure projects or long-term plans, projects that are going to be around for a really long time. And there's so much change that can happen within that time frame. So how do we prepare projects for and design them for long-term resilience and adaptability? What could the future infrastructure look like? So that's what Future Ready is all about. It's about driving that paradigm shift. So it can be difficult to think outside of your current paradigm, the existing codes and standards, conventional design approaches, and really think about emerging trends related to climate, society, technology, and resources. So Future Ready is our approach, and there are three core pillars. I skipped one. There's three core pillars to our Future Ready program. The first is that we seek to better anticipate future conditions by researching key trends in those four categories that I mentioned: climate, society, technology, and resources. So each WSP region, the US being one region, has developed a Future Ready trends checklist. And so that serves as the baseline for everybody to think about these trends and how to apply them to projects. And so the second pillar is then planning for the future by integrating those future trends into our work. And that can be done in a number of ways. Project teams could literally take the checklist and use it at the beginning of a project and identify, what trends do we think are going to impact this project? What could we do to plan for those trends? It could also be researching trends, because there are some trends where we have a decent understanding of what might happen in the future, but there's others where there's uncertainty and we're not quite sure how it could impact our project. So for those types of trends, we might do some research at a global or regional level to try and better understand how those trends could impact our projects. And then another strategy that we've used is conducting future ready workshops. So with the future ready workshops, we bring together groups of multidisciplinary technical experts to really have a structured brainstorming session around future trends, and whether it's a project, a program, a client, a service, how could we better integrate these trends and come up with solutions to address these trends in our work. And then the last pillar is where we're kind of bringing everything together and collaborating with our clients and partners to deliver industry-leading innovations. So that could be a new framework, tool, approach, a number of things of just how to approach a project differently to account for future trends. And why do we do this? It's because of what I mentioned before, that we're working on large infrastructure projects that are going to be around for decades, and we want to make sure that we're being good stewards of our infrastructure. And we know that that current codes and design standards don't keep up with future trends. They're not always accounting for the latest projections in climate change, for example. And once you become a professional engineer, planner, architect, it becomes part of your professional responsibility to make sure that you're accounting for reasonably foreseeable risk. So you can't always just, say, rely on the code. It's getting to a point where we as professionals should be accounting for some of these trends. So we look at trends individually, but we also look at them together, because these trends interact with each other. There can be co-benefits. We don't want to just look at one trend in isolation and solve for that. We want to try and account for multiple trends. And these types of trends, these complex trends, are not easy to quantify. And so that's one of the reasons that our workshop approach can be really helpful, is getting these different opinions from our experts, and really just driving that mindset shift within the company. So this is a quick snapshot of some example future ready trends in those 4 categories, and we will get into the trends in more depth later. But just as a quick snapshot here, when we're talking about climate, we're looking at the physical impacts from climate change. So whether that's heat waves, increased precipitation or less precipitation, sea level rise, and planning for resilience and adaptation. For society, we're looking at different demographic trends. So overall, the US population is aging. There's increased focus on equity and social justice, and making sure that it's not just checking a box, that it's really fully integrated into the process. And climate migration is something that this is where you can start to see some of the synergies between the trends, that because of those physical climate impacts, it's going to result in climate migration in different places. From a technology perspective, we look at connected, automated, shared vehicles, digital transformation, and digital delivery, which is going to then have data security and privacy implications. And then looking at resources, this is where we are trying to reduce resource consumption, lower embodied carbon, and achieve net zero greenhouse gas emissions, work towards a circular economy. Those are some example trends. And this is an example of a future ready checklist. So it's designed to have, so it's got the category, climate, sometimes there's subcategories, and then the trend. And the trend is pretty broad. It's because it's intended to be used by anyone in the US. So one of the things that we often do is, if we're working on a specific project, So if I'm working in a project in New Jersey, then I can tailor these trends to that geography so that they're a little bit more specific, because depending on where you are in the country, the trends are going to have a different impact, or some may not impact you at all. And another way that we look at trends is through a scenario planning process. So traditional planning is you're kind of planning for a single future based on the present by extrapolating from the past. So it's kind of just one line here, when really, in reality, this is what happens. And so scenario planning is an exploratory methodology that helps our practitioners better understand what the implications are of emerging trends, and so that they can think about what the possible futures and what the how the solution could perform under those different scenarios. So it's just trying to kind of push people a little bit further to think about what the future could look like. So in scenario planning, we're posing some challenging questions and trying to think about the resilience of our solutions. So I won't go too in depth to scenario planning. We do have a 5-step process that kind of builds on the future trends. The first is that trend analysis, just researching and better understanding trends, and then also taking a look at likelihood, impact, and uncertainty, and creating anchor points in the scenario process, so that in step 2 you can generate these different alternative futures, and then you can, in step 3, you can screen different areas of impact against those different futures. Then there's step 4, that's a validation with experts. So you want to consult with multidisciplinary group of technical experts to make sure that your assumptions are sound. And then in step 5 is a resilience analysis to assess the potential effectiveness of these different solutions in addressing the implications of the different scenarios. All right, so we're going to go back to Mentimeter and talk about future ready trends. So I'll just give an overview of each category, and then we'll have a question per trend, or per category. So with climate, we're already seeing that climate's becoming more extreme. There's going to be hotter temperatures, more intense storms, precipitation patterns will change, and sea level will rise. So we need to make sure that our infrastructure is designed for future climate change. And so going to Mentimeter. The next question relates to climate. So thinking about your hometown, whether it's in New Jersey or somewhere else, which climate trends do you think will impact your hometown the most? So it's the same Menti link and code. And while you're answering that question, I'll just provide some additional context. So with climate trends, it's important to also think about the time horizon and the life cycle of the lifespan of your asset. So let's say you're designing a building, the HVAC system, maybe that's only designed for 15 years. So when you design that building, when you initially size that system, maybe it's sized more for today, but you design it in a way that a bigger system is going to be needed in the future, and that you design it so that can occur in the future. So it's not always about right away all of that upfront investment. There's also risk-based analysis that you can conduct and see what is the damage going to be under these different scenarios, and what are the most important assets to protect. Maybe you're not making the entire asset fully resilient to certain scenarios, but you're prioritizing the most critical parts of that asset. And there's, I think, probably most of us at this point have experienced some sort of a, extreme weather event. So, we can see how damaging those events can be and how, how much it takes to recover from those events. So, okay, I'm seeing, yeah, heavier rainfall, more intense hurricanes, sea level rise. That makes a lot of sense, especially, I'm assuming a lot of people might be from the area. But yeah, there's going to be, impacts across the board wherever you are. And, these as, civil engineers and other professionals, we're going to have to think about, how do we plan our projects to account for future climate. All right. So back to the presentation. So then we're going to go to the next trend, society. So we know that our workforce will become more diverse in age, gender, ethnicity, and abilities. Artificial intelligence will change the way that we work and interact, and people start to demand change. They'll want to see more, healthier, productive, and efficient spaces. And we've seen some of this during COVID, that streets were repurposed for people and instead of cars. And some of those changes are going to endure as we recognize the benefits of having that kind of space available to us. And back to Menti. So the question on society. So again, think about your hometown and which of these societal trends do you think will impact your hometown? So we have urbanization, the changing workforce, rising inequality, the sharing economy, increasing degree of social isolation, and climate migration. An aging population. Yep, so a little bit in most categories. I think climate migration is one that is harder to predict how exactly that's going to impact different places. And we're seeing that technology is connecting us more, but that can also lead to more social isolation. And with infrastructure, planning for urbanization will be important, and thinking about the shift in demographics, particularly an aging population, will have different needs, different mobility needs, different healthcare needs. So that's something that we'll have to take into consideration. All right, so technology, we're seeing people and objects are becoming increasingly connected to the internet. Autonomous electric vehicles and other zero emission vehicles will change the way that we move around, and we'll have material innovation. New materials will interact with the environment. We'll see demand for materials that have lower embodied carbon. So the question on technology, which technology trends do you think will impact your discipline the most? Automation and artificial intelligence, big data and the Internet of Things, digital delivery, such as BIM and digital twins, blockchain technology, electric vehicles, and modular and adaptable design. seen a battle between big data and automation and AI. Yeah, so I mean, technology is something that it changes so rapidly, and it's really hard to predict. But there are ways that we can anticipate change and plan for it. And one of the project case studies I'm going to talk about example of that. One of the challenges with data is data management. So you collect, there's so much data that we can collect now. You can put sensors on anything. You can monitor all these different things, but if you don't have a good strategy to manage that data and make it usable, then it's just a bunch of noise. All right, so then the last category here is resources. I'm just going to keep it out of the presentation mode. So with resources, we're seeing trend towards renewable energy. It's going to provide cleaner energy, over time cheaper energy, and regulations around resources are changing. So like I mentioned embodied carbon, we're starting to see regulations at the federal, state, and local level around buy clean policies, reducing embodied carbon in major materials like concrete, asphalt, steel, and we're seeing some jurisdictions starting to ban new natural gas lines. So so we're seeing some changes in resources and recognizing the critical importance of addressing the climate crisis. And also materials, thinking of them thinking of a circular economy so that materials at end of life can be considered an asset and reused. And that's where something like digital transformation, digital twins can be helpful in tracking those materials and ensuring that they can be reused later. So then the next question is, how important do you think each of these resource trends are to reducing greenhouse gas emissions? So renewable energy, alternative fuels, resource conservation, circular economy, life cycle assessment, embodied carbon reduction, and green infrastructure and biodiversity. So I'm glad to see votes for all of them because they all are important. So I think some of them are obvious: renewable energy and alternative fuels. Life cycle assessment is really important to understanding the full life cycle of emissions. Not just the emissions from the use of a building or the use of infrastructure, but all the emissions from the materials and the transportation of the materials, the mining of those materials. So you really get the full picture because a large percentage of carbon emissions are actually embodied, so they're already baked into the design phase, and you can't change that once you've designed and constructed something. Whereas with the operational emissions, those could change over time if you shift to renewable energy. And green infrastructure and biodiversity. So there's all this focus on decarbonization, but we need to make sure that it's not done at the expense of biodiversity. Solar energy is obviously important to reducing greenhouse gas emissions, but you have to think of where you put it. You don't want to destroy a forest to put up solar panels. And you just really think about, could you put those solar panels on a brownfield site? Could you put them on more on the rooftop than taking up as much land? And we have one of our project examples shows how you can combine solar panels and agriculture. So thinking again about different co-benefits. And then the last question here is which of these examples does not necessarily reflect a future ready design? So the first is a smart city The second is a transit system that can address rising trends in physical and mental health challenges. A building whose insulation, HVAC, and envelope have been designed based on expected hot days in 2100, and a water quality program to estimate future changes in water use and quality based on increased urbanization. All right, let's see if this works to show the right answer. All right, so the answer is a smart city. So, a smart city definitely could be a future-ready design, but just designing something smart without, ensuring that you're planning for, future trends and that you're considering different impacts of that smart city. It's not automatically a future ready design, whereas the other three examples are looking at trends and trying to design now for these future trends. A little bit of a trick question. Okay. So then I just wanted to share a couple examples of kind of overarching trends and the implications on the different future ready categories. So one major trend is building electrification, and thinking about what are the implications of this trend on climate, technology, resources, and society. So if you think through climate, you want to ensure that this building is going to be resilient to flooding and sea level rise. If you're in an area subject to that'll be impacted by sea level rise. You want to think about the HVAC design that I've brought up before. Make sure that it's going to have sufficient capacity for future projections of heat waves. If you want to eliminate carbon and get rid of any kind of diesel backup generator, do you have battery capacity to serve as backup? Looking at technology, is this a residential or commercial building? Do you expect we're expecting a lot of more electric vehicles in the future. How is that going to potentially impact your electric load? Is it going to be designed to handle that? And then is it going to be designed to integrate new technology like vehicle to grid technology? And another trend that's not always considered is the fire risk associated with electric vehicles and batteries. Does this building have a parking garage? If that parking garage has all electric vehicles instead of internal combustion vehicles, there's a different fire risk and different planning that needs to be done to prepare for that. So those are some examples of thinking through the implications of these different trends. From a resource perspective, just going electric has environmental benefits, but it's not inherently renewable unless you have on-site renewables, or the grid is sourced by renewables, or you're procuring those off-site. And as the demand is increasing for battery storage and electric vehicles, there's more demand for rare earth minerals. And are there the resources available for the battery storage that you need? And can you start to think about what the end of life is going to look like for those assets? From a society perspective, if you're eliminating natural gas, you're improving air air quality for that building, or if you're sourcing renewable energy, you're improving air quality somewhere. And then also, as we shift to zero carbon sources, how do we make sure that equity is considered, that low income populations aren't left out from that transition? And then another example is digital transformation. So this is using digital technologies to create or modify existing processes and user experiences. So, like I mentioned, in many cases, collecting data is the easy part. It's what you do with it. It's how you manage it. and really connecting it to business objectives. So it has the potential to result in positive outcomes in all four categories, depending on how you planned it and how well it's managed. So from a climate perspective, you can have smart systems that react to poor air quality, that could be deploy protections in storm events. From a resource perspective, you can have the ability to monitor energy in real use in real time, and to control your HVAC based on occupancy. And from a society perspective, the digital technology can be used to improve wayfinding and safety, deliver new and unique user experiences, including augmented reality, provide for better comfort and then ultimately productivity. But also need to think about equity and accessibility. What if someone doesn't have a smartphone, or what if someone has a different ability? Are you designing these technologies to be used by everybody? So I will walk through a couple of project examples. So the first one is the Salesforce Tower in San Francisco. This was completed in 2018. I think the tallest structure now in San Francisco. And WSP provided the HVAC system design, also security and IT design to Salesforce Tower. And a couple of ways that we looked at future-ready trends. The building itself was certified LEED Platinum, so there were very strong sustainability considerations as part of the project. And the building uses natural ventilation, so we had to consider the increase in cooling degree days that are going to occur, even though the climate in San Francisco is milder compared to other areas. It's going to change over time. And then knowing the exponential growth in the Internet of Things and the need for bandwidth and networks. So the building was designed with those networks under the floor in a way that they can be more easily upgraded in the future. So we're building the excess capacity that can be activated in the future as needed, knowing that it's going to happen. So that's just one example of you're not necessarily putting all the technology in up front, but you're designing it in a way to absorb that in the future. And this project is the East Parcel Riverfront development in Sleepy Hollow, New York. So this was a former General Motors assembly plant that was a brownfield. The entire site was located within the 100-year floodplain, so at really high risk of flooding. So we were able to take a holistic approach and design this site for multiple uses. So we got rid of a lot of the impervious surfaces and developed some recreational fields that could also be used for stormwater retention as needed, elevated the municipal site that they needed out of the flood zone. So we were really looking at those the current flood, not just the current floodplain, but also what are the projected changes in sea level rise and changes in storm intensity, precipitation, and flooding. Then next is the San Francisco International Airport. So they had a target of net zero energy consumption by 2021. And they, the first step is they had to get a handle on all of their data and systems. They had over 90 building operating facility control systems, over 38 standalone building management systems. So they needed to, they needed our help in designing an energy management control system to really get data from all of those sources. So this was, the solutions that we implemented are, smarter facility control systems. We leveraged data mining and AI-based decision making to, analyze all of this data coming in and converged networks and cybersecurity, because at being an airport, the security of all data is really important. So not only were we able to help them develop this new smart system, but it also directly contributed to over $3.5 million of annual energy savings. And then the last example I mentioned, we had an agrovoltaics example. So this is a solar project in Western Michigan, and they wanted to design and maintain pollinator habitat. And so they didn't want to just mow it regularly. So they worked with us on a unique solution to bring sheep in to graze. So this was, providing for habitat and using, an environmentally friendly way to manage that vegetation. So I think they considered goats initially, but they would jump on the solar panels. So sheep did not have that problem. And that's all I have. So I left plenty of time for questions.